Welcome to part 3 of my video series on making the Stuart 10V vertical steam engine. In this part, I'm going to be making the sole plate, which is the base of the entire engine that the standard and the main crankshaft bearing mount to. This is again a piece of cast iron. Quality looks to be pretty good, but there's a lot of flashing around the edges we can see here. Some on the inside as well, and we're going to have to machine a couple of the surfaces flat, and we end up with a total of 12 holes in here. 8 of them will be tapped. We'll have 4 holes, one in each corner, that mount it to the box bed. We will have 4 drilled and tapped holes for the studs that hold the standard, that holds the cylinder, and then we'll have another 4 for holding the main bearings in place. So looking at this, I think the plan is going to be, first of all, go through and clean up with a file, get rid of the flashing. We've got a protrusion right here where the sprue was from the casting. We're going to need to get that cleaned off in order to mount it flat for machining. And just looking at the way this fits, the top part rocks pretty badly. But if I ignore that one edge, the bottom fits pretty flat. So I think the plan will be to go through, clean it up with a file, put it bottom side down in the milling machine, get a smooth top surface on it, then flip it over and machine the bottom surface that goes to the box bed. Another thing I've decided to do a little differently this time is I'll be using some fast forwarding during the editing, but I'm not going to go through and skip any of the steps. Initially I was thinking that most of the challenges were going to be mounting and machining these parts, but it turns out that getting them really looking good just takes a lot of work with the file. So partly because I was surprised by that and to give people an idea, and so you don't get discouraged yourself, I just want to show you what's involved and the amount of handwork that it takes to take a casting like this and get it looking really good. So over to the vise and the file. I thought about this a little more while I was figuring out how to put it into the mill, and I realized this bottom surface is already looking pretty flat just with the filing. I think what I'm going to do here is just see if we can finish it with some emery paper, and we won't have to bother milling the top side. Noticed there's a bit of a pocket right here in this corner. I don't know if that shows. As well as a couple edges there. I'm thinking if I've got enough left to take off the bottom, I'll want to do that later, but at this point, ready to go smooth off the top and see how this is looking. Like most projects on the milling machine, the challenge isn't moving the cutter around. It's figuring out how to mount the workpiece. When I was first looking at this, I'm going, this is going to be easy. I've got 2 nice big places I can clamp down right on here. In fact, I think I'll put it on a 1, 2, 3 block to raise it up a bit to leave more room for the clamps. Except, I'm actually wanting to mill on those. I could potentially clamp into here, but then if I put the clamp there, I've got to worry about hitting the clamp with the milling tool. I'm not really liking that idea. But I've got these 2 little saddles in the middle, and if I go through and put a rod through, that's going to hold it really nicely. Do it this way. Actually, I think the clamps will be easier. Just took a piece of mild steel bar that I've got that fits inside that slot. Put a couple of flats on it with a file so that the clamps will sit better. And let's see how this holds. The drawing says that it needs to be 1/2 inch plus 1/8 or 5/8, 0.625 from the bottom surface of the sole plate to the top. So I've got a surface height gauge here, which we part of it as things happen. 1, 2, 3, 4, 5, 6, and we're going for 625, but we're at 646, 645 there, and let's check it. If I want to check it on the back, I'm going to need to raise the table or the head. And I'm at 645 on the back. Okay, so I've got 25 thousandths left. On further reflection, I decided to take the extra material off the top to see if I could get this little defect to go away. It didn't work, but didn't get much smaller anyway. Wasn't sure that it would, but I had to take it off one side and avoid making the clamp that way. Anyway, we've got this machine flat. The next step, according to the directions, is going to be cleaning up this slot down the middle that the crankcase bearing fits into. Looking at the drawing for the crankshaft bearing mount on the sole plate, we see there's 3 criteria. First, the slot needs to be perpendicular to the long axis of the sole plate. Second, it needs to be centered in the middle of the sole plate. And finally, it needs to be the correct depth. In order to get the perpendicular part right, we need to make sure that the sole plate is aligned with the long axis of the milling machine. And the way I've decided to do this is raise the sole plate up a bit to make it easier to clamp on a 1, 2, 3 block. I'm going to put some small pieces of aluminum here because these pads will make good mounting spots. And then the clamps won't go through and damage the nice surface that we've already put on the part. And then we'll clamp the part down. Now we need to go through and figure out how do we make sure that it's aligned with the axis of the mill. A wiggler is a really nice tool for the setup that we're trying to do. It's basically a small pointer that's free to move on a ball and socket joint that we can put in the mill and line it up, and it will point at the exact center of where the mill is going to go. It's very nice for going through and lining up a part, for example, when you want to drill a hole in a specific place. Centering the wiggler is really easy. You want to first of all loosen the clamp up so that it's free to move. Turn the mill up to a reasonable speed. You don't want it too, if it's slow, it's hard to do. And just gently touch the tip with, you don't want to use your bare finger, but a piece of wood works nicely. And you'll find that it gets to a point that it completely quits wiggling anymore because once it's on center, anything else would push it to the side. And then you can just snug it up a little bit so that it doesn't move. And we now have this is exactly aligned with the center of the column and center of where the milling tool is going to be. With the wiggler acting as a reference for the center of the milling column, we can move the table back and forth and adjust the alignment of the block until it is right at the edge of these reference points on the casting at both ends. I've picked these as opposed to the bearing mounting blocks because the farther apart the points are, the less angular error you'll have. And this is looking very, very close. Needs to move over just a little more. That is centered. We can tighten down the clamps and make sure that it didn't move. With the wiggler now centered properly, we can use it to indicate off of the two edges of the mounting points for the standard. I'm going to go back to one side, and when you know that it's we'll come in, I'm turning the crank clockwise. There is one edge. I will zero the indicator and I'll measure how far it is to the far side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. With the indicator at one side, I will zero the indicator on the axis, and we will see how far it is to the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 40 thousandths. So if we go back, if we go 12 full turns and 20 thousandths, we'll be in the exact center. I want to go all the way back past the point and come into it, turning clockwise again, so that we don't have to worry about any backlash in the gears. And we're going to go 12 turns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and an additional 20 thousandths. We can now lock the axis on the milling table, knowing that we are centered on the casting. To measure the depth accurately, I've decided to use a dial indicator referenced to a point on the milling head, and the whole head is solid, so any place that I can measure is going to accurately track the up and down movement of the head. And I can then bring the milling cutter down until it touches the block that the sole plate is mounted on, and once I reach there, it'll stop moving no matter what, any backlash in the gears. And that appears to be where it's touching. So that, I now know that the tip of the milling cutter is exactly even with the bottom of the plate. I will zero this out on the indicator, and I need to bring it up 0.281. It's 0.1, 0.2, there is 0.281, and I don't need to worry about backlash because I'm measuring the absolute position of the milling head. I'm now going to set the depth stop as a safety to make sure I don't go below that point. And let's see if that actually stops it. If I bring it down, I hit the stop, I'm at 0.28. Okay, and it consistently stops at 0.281. Give it a visual check. That looks about right. Let's see, did I force it down a little? Nope, that's right. So now I'll bring it up enough to clear the part. That clears, and now it's simply a matter of going through and making multiple passes until I get it down to the required depth. The next step is to go through and put in the 4 holes for mounting the sole plate to the box bed. There's no reference points on either casting for aligning them, so I've just gone through and placed what looks good, looks to be reasonably centered from every way I've looked at it, and going to clamp this down the same way that we did before, remembering to use the aluminum pads so that the castings aren't damaged by the clamps. Again, I used the wiggler to go through and find the exact center of the sole plate. This time I did it in both axes, measuring off the outside edges to find the center. I did a little experimenting with the studs and nuts to see how it would look, and I found that if I use the 1 1/8 spacing that they call for in the drawing from side to side, the nuts end up being a little tight up against these raised areas, so I've decided to go through and move those out to 1 1/4 center to center spacing. So I need to move out from the center 1 1/8 inches to the side and 5/8 of an inch front to back to locate the first hole, and the rest will be from there. That's just a matter of using the dials on the milling table. I have the central drill in. It is close to the clamp, but I do have clearance. So start the first hole. And looked up in the table. This is a number 46 drill, is the correct tapping drill for I'm going to use a tap follower, which just has a spring-loaded plunger in the bottom to help keep the tap straight. All we need to do is put this down, let it compress it a bit, and make sure that I have the tap straight in both directions. For the final assembly, I'm going to use washers underneath the nuts because that surface will be painted and I don't want to damage the paint when tightening them. And the studs will need to be Loctited into the box bed because I noticed they tended to rotate as I was trying to tighten the nuts. But the holes fit very nicely, everything just slipped right together, and it's nice to have the first two parts put together. I'm not going to be able to go any further with the sole plate at this point because, again, to make sure the holes are aligned, I'm not going to be drilling the holes for the standard mount until the standard is complete, and I don't want to do the holes for the crankshaft bearings until the bearing is ready to go in. But so that'll wrap it up for this episode, and hope you've enjoyed it. And if so, remember to subscribe, and I should soon have episode 4 coming up with the next part.